Okay, so now that we have our large star bouncing, falling from the top of the screen, and eventually losing all of its energy and momentum due to friction, we now want to create the next portion of this canvas piece. So if we look at the canvas piece, we know that when these big stars hit the bottom, that they create these little individual mini stars that explode in random directions dynamically. It's all random, and that's kind of the next thing we're going to want to code. So how do we go about creating these mini stars from where we left off? Well, we know that we have one large star object, and that when this large star hits the bottom of the screen, we want to create 8 mini stars. And it doesn't need to be 8, but for our purposes, we're going to be creating 8 of them. Now, we could use this star object to generate those mini stars by just affecting its radius right here, but these mini stars are going to be acting a little bit differently than this large star. They're going to have a different draw function, they're going to have a different update function. It's going to be similar, but they are going to be different, so it's just going to be easier for us to create an individual mini star object function. So that's what we're going to do first. We're going to create a function called MiniStar. And this function is going to resemble all those little mini particles that you see whenever the big star hits the bottom of the screen. So this mini star, like our big star, is going to have some shared properties. It's going to have an x and y coordinate, it's going to have a radius, a color, velocity, and its own individual friction and gravity as well. So some of these are going to be shared, but some of them are going to be different values. But for the shared ones, rather than copy and pasting this code, we can use a bit of inheritance by doing the following. We can call our star object, like so, reference that star object's this, and then each individual property that we want to have copied over directly. So our x, y, radius, and color properties. So what you see right here, and we need to make sure that we actually add arguments for our mini star too. So x, y, radius, and color. What you see right here is going to be the exact same thing as you see right here. The only difference is this is a little cleaner because we're not reassigning things. We don't have to declare this over and over again. We're literally just stating that we want this code to be right here, but we're using inheritance to bring in these properties for a cleaner code because this is a less amount of code than you see up there. That's the only reason we're doing this. We could do this up here, but just for clean code purposes, we're going to be using this method instead. So now that our mini star has an x, y, radius, and color, we know that it needs its own individual velocity and friction and gravity. And these are going to vary, so we're going to just add them directly in here. We can actually just go ahead and copy these and paste it in like so. And then we're going to be editing these values as we continue along coding this. But for just starting off, these values are totally fine. So we're creating the blueprint for our mini star, but we know our mini star also needs a draw and an update function. So we can do the same thing. We can just take this right here, copy our star's draw and update function, and paste it beneath our mini star. Then we're going to copy our mini star function and replace star with mini star. And now our mini star has its own individual draw and update function. So like I said, a lot of this is going to be very similar, but down the line, we're going to be changing things to the point where it differs, which is the whole reason why we're creating a new draw and a new update function for our mini star. So let's go ahead and save that. And we're not going to see anything because we have not created any mini stars just yet. But now that we have the blueprint for our mini star, we've described what our mini star should look like and how it should interact with these draw and update functions. We can now go ahead and create those mini stars whenever our main star hits the bottom of the screen. So where in the code does the main star hit the bottom of the screen? It's this conditional right here, as we commented out within the last video. So we know right here that we want to call some sort of function that creates these 8 individual mini stars. But what should we name that function? Well, let's go ahead and name it Shatter. So when this star hits the bottom of the screen, it's going to shatter, and that's when we're going to create those mini stars, and it's also when we're going to shrink the radius of the big star. So I think shatter is pretty fitting of what happens when this ball hits the bottom of the screen. So since we are calling a shatter function, we're going to need to create that shatter function by saying star.prototype shatter. and this is going to be equal to a function, and inside of here is where all of our shatter code is going to go. So let's go ahead and console log this out just to make sure that things are working as expected. So each time this hits the bottom, we're going to see that we are console logging out shatter, because this is where the ball star hits the bottom of the screen. Okay, cool. So now that we have a method to kind of create that initial explosion with all the mini stars, we just got to go ahead and do that right now. So how many mini stars do we want to create when the ball hits the bottom of the screen? Well, we're going to need a for loop, and we want to run this for loop 8 times. So for each time this for loop is ran, each time it's looped through, we're going to be creating a new mini star. So first thing first, we need something to hold these mini stars and render them on the page, the actual canvas. And we don't actually have that just yet. We only have an array for our big stars, but we're going to want to create another array for our mini stars, because those mini stars should act independently of the big ones. They're going to be having different lifetimes compared to each other, so it's important that we have a way to manage both our main stars and our mini stars. So we know we need some sort of container to contain each individual mini star as we add it onto the page. So we have the main container for stars right now, but like I said, we're going to need one for our mini stars. So we'll declare a let of mini stars. Then we're going to want to assign an array to our mini stars, and this is what's going to manage all of the mini stars draw and update functions. It's going to contain all the mini star objects that we create each time the circle hits the bottom of the screen. Now we're not going to push anything into this until the ball hits the bottom of the screen, so let's go ahead and push something into it right now. So each time the ball hits the bottom of the screen, we want to push in 8 mini stars. So we'll say mini stars. This is referencing the let that we just created right here. And since we're calling init, we're assigning an array to it, so we know that we can push stuff into it. We want to create 8 of these guys right here. So we'll say new mini star. And then we need an x, y coordinate and also a radius and color. So what should the x and y coordinate be for these mini stars when the ball hits the bottom of the screen? Well, this ball could be anywhere on the screen, left and right, when it hits the bottom. So we want to make sure that these mini stars spawn from wherever the ball is and not in just random locations. So we're going to be referencing this.x and this.y for the mini stars x and y coordinates. And this.x and this.y does not reference the mini stars this.x and this.y. Since we are inside of the star prototype right here, this is going to reference the stars this.x and this.y instead of the mini stars this.x and this.y. So if we create a mini star in the center of our big star, they're going to be spawned right in the center whenever the ball hits the bottom of the screen. So that takes care of that, but now we need a radius. These are going to be a lot smaller, so we can just say the radius is going to be equal to 2. And then we need a color, and we're just going to specify red, just so we can easily differentiate between what our mini stars are and where our big star is. So we'll say red. And each time the ball hits the bottom of the screen, we are now pushing mini stars into our mini star array. And we can test this just by console logging out mini stars each time the large star hits the bottom of the screen. So we'll console log that out, get rid of that console log, save things, and let's watch what happens. And you'll see that this array just keeps getting bigger and bigger and bigger each time this hits the bottom of the screen, and it's probably going nonstop, and it is because we don't actually have any way to get rid of that big star at the moment. But don't worry, we'll get to that. Let's just focus on the mini stars right now. So we're pushing all these mini stars into our mini star array, but we're not actually rendering them onto the screen because we never called this mini star draw function or this update function, which calls draw in return. Remember, each time we want to render something on the screen, we need to make sure that we're calling the draw function, which contains all the code that we need for the canvas to know, hey, this is a circle, we should draw it on the screen. So we created our mini star array, but we need to reference each individual mini star and call that update function, which we are not doing right now. We're only doing it for our stars array. So what we can do is we can reference our mini stars array and say for each individual mini star within this array, Let's go ahead and capitalize that. We want to call that MiniStars update function. And in return, this is going to call the draw function and any of the conditional code that we created with gravity and a y velocity that we created for our main star. It's just going to have the same effect at the moment. So if we save this, you'll see we are now generating mini stars. And each time the ball hits the bottom, we're creating 8 of them, but it's only going to look like 1 at the moment because each of these mini stars is being spawned with the exact same x and y velocity. And to get that explosion effect, we need to make sure that these velocities are randomized and different from each other. So let's start off by randomizing these. How do we randomize the x coordinate? Well, we want to make use of a utility function. And within the Canvas boilerplate, there are some utility functions by default, including one that is random int from range. This is going to give us a random integer based on whatever numbers we specify. So if we specify give us a random int from -5 to 5, it'll return us a random number anywhere from -5 to 5 as long as it's an integer. So what we can say is we're calling and importing our utils, which is this file right here. We're importing all of these into this one variable right here called utils. So we can take our utils variable, I believe actually a utils object, excuse me. We're going to take our utils object and we are going to call random int from range. And then we want to specify what that range is going to be. So let's just start off with -5 and 5 and see what happens. Okay, so nothing just yet. So this may be giving our velocity a random value, -5 to 5, but we never actually told our mini star how it should function with this x velocity. You'll see that we're only editing our mini star's y velocity or our y coordinate at the moment. We want to make sure that we're also editing our star's x coordinate with its x velocity. And let's go ahead and save that and see what happens. I think we should have success, and there you go. So we're having this little mini explosion effect where all the stars are kind of going outwards from the center of the circle, and now it's just like a little blood fountain or something along the lines of that. Ooh, I don't know if I like that, but yeah, this is going to be the start of creating that explosion effect. So we have some randomness on our x coordinate, but now let's go ahead and add some to the y coordinate to really give it an actual realistic explosion effect. So we can just copy this, and we're going to replace 3 with, let's just say, -15 to 15, and that'll give it a lot of movement up top. Make sure that these particles are flying straight to the sky and not really lying in the blood fountain like we see right here. So if we go ahead and save that, going to see that we have a much more realistic explosion. But I would really like it for these to go even higher in the sky, and still like this, the blood fountain kind of really amplified its water pressure, blood pressure, really funny blood pressure at the moment. But yeah, let's go ahead and make this a lot higher. Rather than gravity being at 1, let's go ahead and set this gravity to 0.1, and that's going to make sure that things fly a lot higher upwards towards the screen, because remember, we're always pulling down on these particles with gravity because that's what gravity is. And we implement that right here within our MiniStars update function. So if we set our gravity to 0.1, you're going to see we have a much nicer explosion effect. Our particles are flying upwards, and it's pretty crazy still, honestly. It's not like the blood fountain, but this is kind of the effect we want to go for. But now we want to make sure that these particles aren't being generated over and over and over again, as you see right here. So how do we go about that? Well, we know that these particles are only being generated when the ball is touching the floor. So what we need to do is make sure that we get rid of the ball completely under some sort of condition. And that condition is going to be when the ball's radius is equal to 0. Because each time the ball hits the floor, it should shrink a little more and more until the point where it's not even visible, it doesn't even exist. And if it doesn't exist, well, you're not going to see particles being generated randomly over and over and over again. So that's what we're going to do. We want to shrink the radius of our main star whenever it touches the bottom of the floor. So within the star's shatter function, that's when it hits the bottom of the floor, remember. We want to say, when it hits the bottom of the floor, subtract 3 from its radius. And you can set that to any number. The higher the number you set right here for subtracting, the quicker the ball is going to go away. But you'll see right here that eventually, once the ball star actually kind of shrinks into nothing, that we get a JavaScript error. And that's because we're providing a negative number onto our draw function right here, this arc function. And this cannot accept a negative number for its radius. So we need to make sure that this number can never be negative. And the way we're going to do that is whenever the ball reaches a radius of 0, rather than subtract 3 from it again, like we see right here, we are just going to remove it from the array completely, and that way we'll make sure that we cannot call the draw function again when it has a negative radius, because the radius won't even exist. The star will be removed completely from the scene and we'll be good to go. So how do we make sure that we remove a star from its stars array whenever its radius is equal to 0? Well, we'll want to head on down to our animate loop, and we're going to be dealing with this within the stars for each function. So we want to say if a star's individual radius function, or a star's individual property of radius, is equal to 0, and I gotta make sure I wrap this in an if statement like so. So if a star's radius is equal to 0, then we're going to want to remove it completely from the stars array, so we cannot subtract 3 from its radius again. So how do we remove it from the stars array? Well, we need to make sure that we're referencing this star's individual index. So we're looping through each star object within this array, and each star object is going to have an index. And since we're adding another property right here, another variable, we need to make sure that we're wrapping these two in parentheses, and that's just an ES6 feature. We just need to make sure that we're wrapping in parentheses, otherwise this is not going to work as we expect it to. But for each star that we loop through, each star has an index associated with it, and this index we're grabbing automatically because this for each function provides this index for us. So now that we have an individual star's index, what we can do is reference our main stars array, and we're going to use splice. And splice is a function that's going to allow us to remove the star object from the array altogether. Now splice, it takes what? An index. So where within the stars array should we remove an actual star? And then it specifies from that position how many stars should we remove. So at an index of 0, we are going to remove 1 star. And with this in place, if a star's radius is equal to 0, we're just going to remove it completely from the array, and we should be rid of this JavaScript error essentially. So let's see what happens. So it's going to get smaller, smaller, smaller until it's gone completely. We're not spawning all those mini stars over and over and over again, which is great. So you're going to notice that the mini stars, they disappear a little differently than the large stars. The large stars disappear based on their radius. Once it shrinks to 0, we get rid of them completely from the stars array. But the mini stars, they disappear after a set period of time. And after a set period of time has elapsed, that is when we remove them from the mini stars array. So we're going to do things a little differently to make sure that whenever these mini stars are spawned on the screen, after a specific amount of time, they're going to fade out, and we're going to remove them from the array completely for efficiency purposes. So how do we go about removing these mini stars from the scene? Well, we're going to want to give these mini stars a new property called TTL, and this is going to stand for time to live. How many frames should these mini stars live for? And I'm going to specify that they should live for 100 frames. So we can declare this. And now they have a TTL variable, a TTL property, but each time a frame runs, as a frame runs for each time this update function is called, we're going to want to subtract 1 from the time to live. So this way we're specifying, hey, this really only does have 100 frames to live. And once this time to live value is down to 0, this is when we're going to remove the mini stars from the mini star array. So we're going to want to do the same thing that we just did for our stars array right here. Instead of removing stars from the array when the radius is equal to 0, we're going to remove mini stars from the mini stars array whenever their time to live is equal to 0 instead. So we're just going to do the exact same thing we see right here with a little bit of different properties. So if we go ahead and copy this conditional, paste it down here, and remember we're referencing a mini star instead of an actual star. and then we're referencing our MiniStars array. And then we want to make sure that we're splicing MiniStars from our MiniStars array. So we're going to make sure that we add index right here. If we save this, we're not going to see anything just yet. We want to make sure that we change all of these properties to match up. It's not when our MiniStars radius is equal to 0, it's when its time to live is equal to 0 that we want to take it out of the MiniStars array completely. So over a specific amount of time, after 100 frames have elapsed, you're going to see that these MiniStars are just removed from the screen completely. So I realize that might be a little confusing, but let's go ahead and take it step by step real quick, just so that we can have the best understanding possible. So we just gave our MiniStars a specific amount of time to live, which is 100 frames. For each time our MiniStars update function is called, we're going to be subtracting 1 from that time to live value. As a result, we're calling update right here, which means each time update is called, we're subtracting 1 from the time to live value. Eventually, that time to live value is going to be equal to 0. And once it's equal to 0, all of our MiniStars, they're inside this MiniStars array that we created in the beginning. Once the individual MiniStars time to live is 0, we're going to be removing it from that main MiniStars array by using the splice function and index, which is provided to us through this for each function. So it's a lot to kind of congest, especially if you're new to coding, I'm sure, but really just try to kind of digest what I said as much as possible, and maybe even research a little bit of what you're confused on. I really want to make sure you guys have the best understanding possible, but for time's sake and just how much I know, that's probably about the best way I know how to describe it. So we're not done just yet. If we look over here, we're removing these from the screen, but we're removing them when their opacity is equal to 0, essentially. So rather than having this harsh effect where if I refresh the page over here, each individual MiniStar is just removed from the screen completely when its time to live is equal to 0, rather than have that harsh movement effect, we want to make sure that we're fading these particles out based on each individual particle's time to live. So we're going to want to add one more property. A MiniStar should also have an opacity which is equal to 1 to start. And we're going to want to shrink that opacity down to 0 based on our MiniStar's time to live value right here. So whenever we're updating a MiniStar, we want to deal with this update function. But to actually get that fade effect, we're going to go to our draw function for the first time. So we have a fill style that references this.color, and we're assigning a color to our MiniStar up here in our stars prototype as Shatter, and that color is red. Now, we can keep a red color, but we can't really just assign this as red. We're going to assign this as an RGBA value. And that's what's going to allow us to create that fade out effect, because we can use RGB values to specify an actual color, but we can also use an alpha value, which will help us fade that one color out until we can't see it anymore. So here's what we're going to do. We're going to get rid of red from right here when we're pushing in a new MiniStar on line 58. We can save that. We're not going to see any color over here because we haven't specified a color for the MiniStar. Well, actually, we have. It's just taking the main star's color. So all these are going to be blue. But we know that we want to fade this color out. So if we go back to draw, we're referencing a color. Instead of referencing a color, we're just going to hard code a color in here. So follow after me. We are going to be using tick marks. The tick marks are on the top left-hand side of your keyboard, and we're using these for ES6 purposes. This is a way in which we can type out a string, but also put a variable inside the string in the cleanest way possible. You're going to see it as we type this out. So tick marks, and then we're going to create a string of RGBA. And to make a red star, we want to reference a value of 255, 0, and 0. This is the red value. 255 means we're making it exactly red. 0 means we're not putting any color into a green value, and 0 here means we're not putting any color into a blue value. So this is going to be pure red. And then we have an alpha value right here, which is going to be equal to 1 to start. And if we save that, we're back to red, which is great. But we need to edit this value right here. You'll see if I make this 0.01, we're going to have, you can't even see the particles because they're so light. Let's go ahead and make it 0.4. we're going to have really faded out red particles. So this is, if we edit this value over time, these particles are going to have a fade effect. So we're going to want to reference our opacity right here. And to reference our opacity, what we can do is make use of this new ES6 feature where we type a $ and curly brackets. And if we do this, we can implant a variable directly into this string because we made use of these tick marks. So we can say this.opacity, and it's going to reference 1, but we need to edit this opacity over time. So to edit anything over time, we're going to go straight back to our update function. We're subtracting our time to live value by 1 each time update is called, but we're also going to want to affect our opacity value as well. Now we're going to want to say, each time our update function is ran, take our current opacity and subtract. We're going to want to subtract a certain ratio from our current opacity based on time to live. So we can say subtract this.ttl, and this will go ahead and subtract 100 each time update is ran. But remember, we don't want to subtract 100. We're going to want to subtract an even smaller value, because if we subtract 100 from 1, we're going to have something like -99, and you can't have an opacity of -99. You can only have a value of 0 to 1. So rather than subtract 100, we can divide 1 by 100 instead, and this is going to make sure that we're subtracting 0.01 from our opacity rather than 100, because we're making this 100 value into a ratio instead. So if we save things, you're going to see that our particles start to fade over time. And since we're referencing a time to live value and we're using 1 to divide that time to live value, we can affect this right here. We can change this value, and this is going to determine how long our particles should actually live. Remember, we're not going to remove our particles until this time to live value is 0, and our opacity is going to be affected based on this time to live value. So our particles will fade exactly as we expect them to, and they're going to live as long as we specify within this TTL. So we change this to 50, they're going to go away really quickly, and if we change them up higher to 100 or something, whatever you want it to be, they're going to go away less quickly. All right. A lot to digest, I know, but that's basically the gist of it. That's going to be the hardest part of this. It's pretty smooth sailing from here. We're going to be drawing shapes. We're going to be drawing multiple stars that fall from the sky and adding good colors into this so we get that effect that we see over here in the actual canvas piece. So like I said, guys, I understand this is a lot to digest. Take it slow down the video if you have to, pause periodically, write things down, really try to digest and understand what I said and the thought process behind all of this. It's the most important part, is just taking things one step at a time and trying to digest everything so that you actually come out with a good understanding. If you guys have any questions so far, please feel free to leave them in the comments of this video, and I'll be sure to answer. Otherwise, I hope you guys enjoyed the video and got something out of it, and we'll be moving on to the next lesson to start drawing shapes in the background and making this thing a lot prettier than it is right now. I'll see you guys then.